And go for it.
How about it?
All right, great. I'm sure I'm in control here. Yep. Okay, good. Welcome, everybody. Thank you for joining us today. We're going to get started because we have much to cover. The purpose of today's, purpose of today's roundtable is to provide a forum for knowledge sharing among the many resource managers and scientists who work in the space where aquaculture and eelgrass overlap. And we hope to increase awareness of region-wide efforts, perhaps even highlighting potential collaborations, and to shine a light on scientific and regulatory gaps and opportunities for solutions. While the geographic focus of our presenters is the Gulf of Maine, the relevance of the topic goes far beyond our region. So it's our hope that the outcomes from this roundtable are transferable and informative elsewhere. The agenda on the right shows our plan for the afternoon, with a keynote beginning shortly, followed by lightning talks from researchers and regulators from New England states and Canadian provinces along the Gulf of Maine. And then we'll have a brief break after the lightning talks around 2:30, followed by small group breakout sessions and a share out discussion, and then we'll adjourn at 3:30. A few housekeeping items. Please do add your affiliation to your Zoom name and remain muted during the presentations. The meeting's being recorded, aside from the breakout sessions where we want participants to feel like they can speak as candidly as they like. Please use the chat box and the raised hand feature during the Q&A periods. And finally, we ask that you please be present during the breakout sessions. So keep your camera on and your mic unmuted when we get to that part of the agenda. With that said, we'll take a moment now to introduce ourselves as your hosts. Danny, would you like to come off mute and start?
Sure. Yeah. So I'm Danny Badger. I'm with MIT Sea Grant. I'm focused primarily on sustainable aquaculture, but one of the big angles that I've been seeing is that there's a fair bit of frustration, confusion, and concern around how best to operate around eelgrass, and are there opportunities to enable everything to live in a kumbaya existence. So my big goal is to hone in on the best practices for the whole industry and conservationists as well.
Great. And I'm Jill Carr. I'm the coastal data scientist for the Mass Bays National Estuary Partnership. Mass Bays is an EPA designated national estuary program that works to support healthy and resilient estuaries across Ipswich Bay, Massachusetts Bay, and Cape Cod Bay. And we're invested in today's topic because there are still so many unknowns around how eelgrass and aquaculture interact. We've heard anecdotal accounts across the spectrum, from a symbiotic coexistence to very negative associations to management challenges. So it's our hope that by bringing science and management together, we can start to work toward greater sustainability and hopefully success for both eelgrass and aquaculture. So now that we've both introduced ourselves, it is my pleasure to introduce our keynote speaker. Here we go. We're so pleased to be able to kick off the presentations with a keynote by Dr. Lee Howarth, who is a research scientist at the Center for Marine Applied Research in Nova Scotia, Canada. Lee's work weaves in both a local and global perspective, as he was born in Hong Kong, completed his PhD in the UK, and in 2018 moved to North America for a postdoc at Dalhousie University. And since then, his research has focused almost exclusively on the way that aquaculture interacts with surrounding environments. And he works closely with a variety of government agencies and industry leaders in his work. So with that, it is my pleasure to welcome Dr. Lee Howarth.
Thank you very much, Jill. Can everyone hear me okay? Great. Okay, yep, so hi everyone, my name is Lee Howarth and I'm currently based at the Center for Marine Applied Research here in Halifax, Nova Scotia. And one question that repeatedly comes up in Nova Scotia, and in fact many other parts of the world, is how exactly does aquaculture impact eelgrass? Should we be concerned? And if so, what can we do to better manage for it? And all this work I'm about to present is recently came out in our new paper, which came out earlier this year, and it is freely available. So there's nothing stopping you from reading it in bed tonight or even taking it with you on your next vacation. So first things first, what exactly is eelgrass? So eelgrass, as its name suggests, is a type of aquatic grass, which means it has roots, flowers, seeds, and all those other characteristics we're used to seeing in terrestrial plants. Now, although there are something like 60 species of seagrass all around the world, eelgrass is the single most abundant species in Canada and the USA, stretching all along pretty much the east and west coasts. It's also really abundant throughout Europe and the Mediterranean seas, and it's also in Korea, Japan, China, and Western Russia. So it's very, very widespread. So now we know what it is. Why exactly is it important? Well, seagrass is often described as being an ecosystem engineer for its ability to modify its physical, chemical, and biological environment. So if we imagine this coastline on the left here, it has no seagrass cover, so strong waves are hitting the shore, which is causing greater levels of coastal erosion and high turbidity, just making the water more murky. Whereas in the picture on the right here, the structure of the seagrass is slowing down the movement of the water, which is reducing erosion, and it's also encouraging suspended settlements in the water to settle onto the seafloor, which is improving water clarity and allowing more light to penetrate to greater depths. At the same time, the roots of the plants are enhancing sediment stability, and they're also trapping detritus and organic matter, which is increasing sediment nutrient concentration. So as a result of all that, eelgrass beds can come to support huge, diverse communities of seaweeds and benthic invertebrates like worms, shrimps, and snails. And all these animals can then provide greater feeding opportunities to a range of larger organisms like crabs, scallops, juvenile cod. And this is why eelgrass is often described as being a nursery habitat. And all the eelgrass and its inhabitants can then provide habitat and food to many migratory aquatic birds. And it's for all these reasons why eelgrass is protected in many countries around the world. Unfortunately though, eelgrass has declined all over the world due to many interacting stresses. For example, eelgrass can be easily physically damaged and uprooted by activities like aggregate dredging, fishing, boat propellers, anchors, and moorings. And if we look at the picture on the right here, we can see that there's a clear radius of seagrass missing underneath every single boat there. And that's because the boats are swinging around in circles every day as the tide comes in and out, which is damaging the underlying eelgrass below. Now, eelgrass, like all plants, require light for photosynthesis. So obviously any disturbance that's going to reduce light availability is going to have a strong negative impact on eelgrass. And there are loads of ways that eelgrass can be shaded from the light, including the constructions of marinas, wharves, buildings, as well as sedimentation from storms and rivers. And studies show that reduced light levels can reduce eelgrass biomass, shoot density, and tissue sugar concentration, which can then lead to their mortality after about 4 to 6 weeks if light levels are not restored. Eelgrass are also highly intolerant of being buried underneath the sediment, and studies show that eelgrass mortality can be as high as 75% if they are buried up to just a quarter of their height for about a month, and that mortality can reach 100% if they are buried up to half of their height. So eelgrass really do not like being smothered in sediment at all. However, it's actually eutrophication, which is considered to be the greatest threat facing eelgrass today. So this is when human activities can release nitrogen, phosphorus, and other nutrients into the sea, which can then encourage the development of phytoplankton blooms, which naturally makes the water more murky and reduces light availability. Higher nutrient loads can also promote the growth of epiphytes like algae and hydroids, which grow on the blades of the eelgrass, further blocking it from the light. And higher nutrient loads can also promote the growth of seaweeds, which can grow really quickly and outcompete with the eelgrass for light and space. And the problem doesn't stop there, because once all this plant matter and the plankton matter starts to decompose, it reduces oxygen, which can cause an increase in sulfides, both of which can reduce eelgrass growth and survival. Lastly, the release of nitrogen in the form of nitrate and ammonium can be toxic to eelgrass in very high concentrations if exposed for very extended periods of time. And it's probably about now you're asking yourself, what on earth does any of this have to do with aquaculture? Well, aquaculture actually has the potential to interact and exacerbate all those impacts we just discussed. So if we look at intertidal shellfish culture first, these pictures show various forms of clam, oyster, and gooey duck aquaculture. And it's easy to imagine that any eelgrass underlying these gears could be shaded and physically disturbed. In fact, this picture on the right here shows some hanging bag oyster farms in France, and you can see it's directly overlying and shading the eelgrass growing underneath. Also, the workers themselves and any equipment they use, like high pressure water hoses, ATVs, and so on, will also likely disturb any eelgrass in the area. And there are lots of studies to support this. So a study in Washington State found that hanging bag oyster aquaculture caused a 75% decrease in eelgrass cover after a period of 18 months, whereas rack and bag culture caused 100% loss. On a larger scale, a global meta-analysis by Ferris et al. Found that pretty much every form of intertidal shellfish farming reduced eelgrass density and biomass, but paradoxically caused an increase in eelgrass growth and seed production. And it's believed to be that this is because any eelgrass that does survive and remain benefits from having less neighboring eelgrass to compete with for light and space. And also increasing seed production is considered to be like an evolutionary response, which can help eelgrass beds survive and re-establish themselves after disturbances have gone. Lastly, this global analysis also found that mechanical harvesting methods, like the use of mechanical dredges, high-pressure water hoses, they often have greater impact on eelgrass than hand harvesting methods like the use of hose and rakes, presumably because it's easier to more spatially target what you're doing with your hand harvesting tools, so therefore perhaps it results in a smaller area of disturbance. So some potential management recommendations here could include, number one, simply avoid placing intertidal shellfish farms directly over eelgrass, and maybe use a spatial buffer around any existing eelgrass beds to allow the eelgrass to expand in constricted size as they undergo seasonal and annual fluctuations. And number two, maybe try and promote harvesters to use hand seeding and hand harvesting methods rather than mechanical methods, because generally mechanical methods usually result in greater amounts of disturbance. Now, moving on to suspended shellfish aquaculture, which includes methods like mussel longlines, scallop lantern nets, oyster go cages, and even these floating rafts. All these methods involve suspending shellfish in mid-water or just below the water's surface. And in most cases, you can actually sink the gear to the seabed to, avoid impact and damage from storms and sea ice. So in these cases, direct physical disturbance to eelgrass is usually less of an issue, but it can still occur if the anchors and moorings themselves are located in eelgrass beds. So straight off the bat, some simple management ideas could be, number one, try and minimize placing anchors and moorings in eelgrass beds. But if you do have to do it, try and do it in the winter when sedimentation and turbidity are already high, and the eelgrass won't be heat stressed like they could be in the summer. Generally though, most studies indicate that shading is actually the primary impact of suspended methods, which can reduce eelgrass density and photosynthesis for a radius of about 25 meters around the farms. However, some studies on the west coast of USA have shown that increasing the spacing between the gears tends to result in less impact to eelgrass. And that meta-analysis I mentioned earlier found that suspended long lines tend to have more of an impact than suspended bag methods. And for this, there are two possible reasons. The first is that suspended bags may simply allow more light to penetrate to the seabed. And a study from Australia found that suspended bag methods actually created 68% less shading compared to other suspended methods. And the second reason could be that growers that use suspended bags in regions like New Brunswick and other parts of the world tend to actually put some slack in their lines, and that reduces strain on the gear, but it also has the unintended benefit of allowing the gear to move and sway with the tides day in and day out, and that prevents any area of the seabed from being permanently shaded. So that would also create less impact to eelgrass. So some possible management ideas here are, one, perhaps encourage greater spacings between gear, and number two, encourage growers to put some slack in their lines to allow the gear to sway with the tides and not permanently shade any area of the seabed. However, you need to make sure that this doesn't go against local government advice, because here in Nova Scotia, the government actually suggests that we keep our lines really tight to reduce wildlife entanglements. So perhaps this option isn't available everywhere. I should also quickly mention that some scientists argue that shellfish farming can actually benefit seagrass in some circumstances. And that's because the filter feeding activity of the shellfish can remove plankton and other organic matter from the water, which can reduce turbidity and improve light availability. At the same time, the shellfish are excreting solid and dissolved waste into the water, which contains nitrogen. So theoretically, shellfish farms can benefit eelgrass by increasing the amount of light and nutrients available. And in fact, there have been several reports that suspended mussel and oyster farms has increased the density and growth of seagrass in Mexico, New Zealand, Florida, and Japan. And in fact, the studies from Florida and Japan suggested that shellfish farming can actually reduce the amount of epiphytes growing on seagrass. And it's thought that perhaps it's feeding on like benthic diatoms and algae from the water before they actually have a chance to settle and colonize the seagrass below. And lastly, moving on to finfish aquaculture. And one of the primary impacts of finfish aquaculture is the organic enrichment of the seabed. And this is where uneaten fish feed and fish poop settle onto the sea floor, which then decompose, which can then reduce oxygen and increase sulfides. At the same time, the finfish are directly excreting nitrogen into the water as they effectively urinate. So if you recall from the beginning of this talk, oxygen depletion, sulfides, and high amounts of dissolved nitrogen can all negatively impact eelgrass. But is there actually any evidence of this? Well, there are actually loads of studies on this subject dating all the way back to the early 90s. However, pretty much every single one has examined the effects of finfish farming in the Mediterranean Sea, which is a different region, on a completely different species of seagrass called Neptune grass. So different region, different species. In general, though, these studies show that seagrass tends to be entirely absent underneath the cages and is usually reduced around the cages for a radius of about 300 meters. And these declining trends have been linked to higher amounts of dissolved nutrients, organic matter, sedimentation, epiphyte loads, and increased grazing pressure from sea urchins, parrotfish, and other herbivores. However, I don't think I need to tell you that Mediterranean fish farms are very different to those that we have in Canada, Scotland, Norway, Maine, and many other parts of the world. There's huge differences in turbidity, ambient nutrient levels, and even the species Neptune grass is very different to eelgrass. So perhaps these studies are not the most relevant to Maine, Canada, and other temperate regions. So this asks the question, are there any studies from temperate regions? Well, surprisingly, there's only been one single study to date, which was conducted here in Nova Scotia. I don't actually have the time to go into the results, but overall, the results were kind of a mixed bag. And I should say that this fish farm is a very unusual one, as it's located in a very shallow, sheltered, and muddy bay, which is very atypical for fish farms in temperate regions, particularly in Nova Scotia. So potentially, this study may not be the most representative of other areas around the world. And overall, I feel strongly that this topic, finfish aquaculture in eelgrass, really does require greater study, because as it stands, we really don't have much of an idea how finfish farming can impact eelgrass in temperate ecosystems. So that was a whistle-stop tour, but just to briefly wrap up, eelgrass is declining all around the world due to many interacting stresses. However, shellfish and finfish farming can exacerbate these, including physical disturbance, shading, sedimentation, and eutrophication. Now, interestingly, the effects of shellfish and eelgrass have been well studied all around the world, whereas the effects of finfish farming on eelgrass, there's only been one field study to date. Overall, the field could really benefit generally from more studies to assess eelgrass survival, growth, and recovery processes in response to different production and harvesting methods, gear spacings, stocking density, and culture fallow durations. And it's exactly this kind of research which could really help regulators establish unambiguous operational and siting guidelines that could really minimize the potential for any negative interactions. So before I finish, I do have to thank you to everyone that was involved in this project, including Joseph LaBelle and Jeff Burrell, who I believe are both here today attending this workshop. So thank you to all of them, and thank you to you all for listening.
That was great, Lee. Thank you. We have a few minutes. We have about 5 minutes where we could ask some questions of Lee. You are welcome to put those in the chat, although it'll be faster for you to raise your hand using the little reactions tool on the Zoom toolbar. Pam DeBoner?
Yeah, thank you. Thank you very much, Lee. That was really terrific, and I'm amazed at how much you covered in such a short amount of time.
Yeah, so I was speaking as fast as I could. That's not a good idea.
We can play it back at half pace in the recording. I wonder if you can make some comment about, on balance, what your sense is of the good versus bad, because in terms of aquaculture and eelgrass, because you had some examples of studies where it looks like it might be good for eelgrass, but there are a lot of caveats about where do you place things that are bad for eelgrass. So I'm just wondering,
Yeah, of
where
course.
do you come down?
Right. So I should give you the caveat that I am not an eelgrass expert. I just happen to be the person to bring all the research of others under one roof. Because at the moment, at the time, there was no single report you could go to that had all this in one area. So that's the reason why I wrote a paper and a report on the subject. But I haven't actually ever worked on eelgrass in my whole life, and I've only seen it in the wild a few times. So I'm not an expert. Like I said, I'm just the dope that put it all together. But all I can say is there is that global meta-analysis by Ferris et al., which is really, really good work. And generally from that, it seemed like most of the results that were to do with shellfish farming in eelgrass, generally it seemed like the trends were more negative than positive. But the negative results, when, like, in my opinion, they were never that striking. It just seemed that, like, yeah, if you put a shellfish farm directly on top of eelgrass, chances are more likely it's not going to be good for the eelgrass, but the effect will be very spatially very small. It will be confined to that lease area. Whereas with finfish farming, on the other hand, we don't really know what's going on. But if we take the evidence from the Mediterranean, because we have those fish cages tend to be in slightly deeper water at least, so you've got this greater footfall of the poop and the uneaten feed hitting the seafloor. The radius of the damage there tends to be a lot larger, but there's actually been so little research on it. So my hunch is that it's more negative than positive, but the negative effect is very, very confined to like 25 meters around the lease. So I think it's up to us, the managers and regulators, to create the balance.
Thank you.
Chris?
Yeah, hi. Great presentation. Thank you. One thought I had is, obviously, if you look at this across the globe, you have different regulatory structures. And I'm wondering if that came up in your paper in regards to, country-specific differences in aquaculture that might have driven some of the observations.
Yeah, I originally wanted to look into that for the peer-reviewed paper. I found it quite difficult to find that information out, because actually just answering, so in the report that's on our website, www.cmar.ca, I go into just how Canada manages aquaculture in eelgrass, and it took me months of phoning people up, trying to figure out exactly what the federal government stance is, what the provincial government stance is. So I think just diving into one region of one country is actually quite tricky, because it can be difficult to know exactly where the government stands with this. So I didn't go that into deep detail, but for our report, what I did do was I presented a big case study about New Brunswick, which is our next door neighbor here in Nova Scotia. And I talked about their regulatory regime. And I believe Joseph LaBelle is actually here from New Brunswick, and he's going to give us a presentation, I'm guessing, on the system they came up with there. And what I loved about their system and why I put so much emphasis on it was because it can be really easy to say we need more data on eelgrass. We need to know where the eelgrass are, and we need to do all these drone surveys and scuba surveys and camera surveys. Whereas, like, what I liked about New Brunswick was they said, we're never going to have the resources available to do that, but what we can do is we can still make decisions. So they came up with a system that, providing growers adhere to their operational guidelines and providing no one expands beyond where the lease boundaries are meant to be, they believe that no matter how much aquaculture will grow, providing it sticks to these set of rules, it will never actually impact eelgrass at an ecologically significant scale. So I really liked their system there. It's kind of just acknowledging it's very difficult to get more data. Decisions still need to be made, and therefore here's a system that's a good compromise. So I'm going to leave it to Joseph to talk about that later on, if that's okay.
Great. We'll just take one last question or comment from Cressida, and then we'll be moving on to our lightning talks.
Oh, sure. Thanks. Yeah, great. Really great summation and summary presentation, Lee.
Thank you.
Thank you for that. But I have a question, and I'm taking the opportunity because you had the chance to look at all these papers across so many areas. But have you seen any examples where given that if certain actions are taken, as you suggested, on the parts of, growers, etc., that there will be a recovery or a chance for recovery, or is it too late, depending on conditions or how long a farm has been there, for eelgrass to come back?
All right, I have 2 points to try and address, and I'll try and remember both of them. But yeah, the first one was I was surprised how few studies, like, for example, made a long line mussel farm, and in this area they had greater spacings between gear, maybe less stocking density, and compared the two, I was actually surprised at how little studies there are that had done that kind of thing. So I felt like, personally, if I recall, I don't think there was much research into that, which I think is a big gap. But the second thing is that when you're looking at eelgrass recovery, it's incredibly difficult, because we already mentioned eelgrass is already being stressed by 100 things that aren't even aquaculture related. And no matter where your study is going to be, the chances are it is warming, it's increasing in acidity, it's probably already been subject to wasting disease, there's probably eutrophication going on, and now you also happen to have a mussel farm in the last 30 years. And at the same time, eelgrass beds are very, very dynamic. I can't believe how much they're constantly expanding, contracting, disappearing, reappearing. So when you just do a simple 2-year study before, after, or do this, do that, I think it really gets hindered by the complexity of the system. So I just want to put that in its defense at the same time.
Great answer. Thank you so much for that. I feel like we could keep going all afternoon on this. We are going to move forward with our lightning session now. Thank you again, Lee, so much for that presentation. If you're lucky enough to have Lee in your breakout room, you can keep the conversation going a bit, or in our discussion that will follow that. But for now, we're going to get into those paired talks for the next 65 minutes. Lee being from Canada himself, we're going to sort of call him the scientist perspective. And next we'll be hearing from a regulator from Canada. And we're going to hear from Joseph Labelle from New Brunswick.
Good afternoon. Can you hear me?
You sound great.
Excellent. Good. Okay, my name is Joseph Labelle. I'm with the New Brunswick Department of Agriculture, Aquaculture, and Fisheries. And we are the regulator, the licensor, and the leaser of marine space for aquaculture in the province. So if we go to the next slide. So we have finfish salmon farms in the Bay of Fundy, and we have shellfish aquaculture farms on the east coast of New Brunswick. So we have 98 finfish aquaculture leases in the Bay of Fundy, and we have 498 leases on the East Coast, almost exclusively American oyster. And the expansion and the primary production is coming from floating aquaculture, floating bag culture of various sorts. In terms of tracking what we have for eelgrass, we've got mapping from 2007 through 2011 from field observations, from aerial photographs, some sonar data. We've got more recent material from 2019, 2022 through sonar data. Recently, there's data coming in from 2021 and 22 from satellite imaging, and there was a little bit of LiDAR sampling done in 2014, 2016. So in terms of one of the questions is, what are the trends in eelgrass? Well, we're not quite sure. Fortunately, today we have Jeff Burrell, who is our guy on exactly what's happening with eelgrass. We're not quite sure. We used the mapping in 2011, 2013, and some more recent stuff for our regulatory framework. And hopefully the satellite imagery from 2011, 2021, 22, it seems promising, and it'll probably show us more year-to-year variability, but we'll wait for Jeff and his folks to come up with some conclusions on that. So the next slide. So this is the East Coast, where we have information on eelgrass, and all those red areas are what we call bay management areas or aquaculture management areas. So these are in their estuaries. Most of them are protected by either islands or sand dune structures on the outside. They're very shallow, and that's where the aquaculture development has taken place. We have floating bags, which is the top right hand. Let's go back. Floating bags, which is the top right hand side, where there are Vexar bags with floats. And then there are oyster grows, which is the lower photograph there, that have the same Vexar bags for oysters, but they're stacked 3 or 6 bags to a structure, to an oyster grow structure. And those are used to flip, so that we get rid of and clean them up. Our regulatory framework on the next slide is through the New Brunswick Aquaculture Act. We have a new act, 2016, that came into effect July 1st, 2022, and the general regulation under the Aquaculture Act. You require a license in New Brunswick to carry on aquaculture. The maximum term for a license is 20 years, but through policy, we issue a 10-year license for operations. And if you want to use provincial submerged lands, you must obtain a lease that goes with that license. And there again, the practice is to issue a lease for a 10-year period. The major considerations involved in whether a lease will be issued in a location or not is whether it conflicts with other users of the surrounding waters. That can be First Nations use, it can be recreational fishing, it can be small scale commercial fishing, it can be recreational boating, navigation requirements, different elements like that are considered, and also a consideration whether the operation would constitute an unacceptable environmental risk. So that's based on the materials that are provided mostly through DFO's process of science reporting, and that constitutes the material from which these decisions are made. Another important part of the Aquaculture Act is something called aquaculture management areas, which is a tool available to our minister to issue an aquaculture management area order, and this can contain specific provisions that apply to all the leases and all the operations within that area. And the final component is the farm management plan requirement, which is a tool that we have. Next slide. And maybe we could go on to the, since I'm running out of time, go on more slides forward, please. One more time. So what we have is we have bay management plans, and these plans have buffer areas for birds, buffer areas to protect shorelines. It has leases. We do that by depth. This map shows on the right-hand side, the pink area on the right-hand side is eelgrass presence, and you can see where the licenses are outside of the eelgrass presence from the information that we had at this point. All of this planning is based on 2 exercises that were done in 2005 and 2013, called a replacement class screening or comprehensive environmental effects determination, where all the pathways of effect looking at the habitat were considered and mitigations measures were identified through that. And the mitigation measures, particularly for oyster aquaculture, are siting of anchors of appropriate size and installing them permanently. So those are installed in the winter and they're permanently installed, so they're not moving them around. And spacing the rows of the works or the gear a minimum of 3 meters apart. And we also have within that framework a 10% maximum bay coverage in terms of lease space. So if we were to extrapolate in terms of what kind of impacts that might have, we're down to if the maximum space were to be leased and the space were to contain a maximum amount of gear, it would be 3.3% of the lease or 0.3% of the total bay area, because we have a maximum of 10%. One study indicated that we could see a reduction in biomass of eelgrass immediately under the cages of up to 30%, which would mean that the total impact on eelgrass within a bay would be 0.1%. And we think
Joseph,
that
can
is,
we maybe another just 15 seconds to wrap up your thoughts?
Yeah. Okay, questions for the science folks. We issued leases for a minimum of 10 years. In order to consider eelgrass, we need a pretty good understanding of where eelgrass exists. So that has been a problem in the past. Every time we do a survey, we get a different result. When it comes to managing the bays, we have to still come to some determination. And I'll leave it at that, but prepared to answer any questions you might have. Well, one last consideration. I don't think that you can look at eelgrass or aquaculture unless you do it within the context of a general area. Okay? And I think that the bay management approach, bay management is vital to do that, not only so that we can compare and see what's happening in different places within the bay, but that we can consider the cumulative effects of the activity. And that's why we have a 10% ceiling. But it's also vital to the proponent that wants to put a lease in. So if you have pre-identified areas that you've screened through, then instead of every proponent having to go through all of this process to identify their particular areas, as a regulator, if you do that ahead of time, what you end up doing is provide more clarity. There are areas where you just won't get a lease because of they're defined in the aquaculture management area plan. So that is what we see as the great advantages of the bay management framework.
Great. Thank you, Joseph. And I just want to plug a note in here. You are welcome to put your questions as they come to you in the chat. That's perfectly fine. And the speaker can be looking at the chat and answering you there, or we can pull up those questions at the end of the lightning round. But do feel free to use that so you don't forget your questions for folks. The next talk we're going to be hearing from Maine. It's a unique situation where Dana Morse from Maine Sea Grant is actually going to cover both the scientific and the regulatory aspects. Unfortunately, his regulatory counterpart, Cheyenne, could not be here. Her contact info is there in case you need to reach her, though. So Dana, welcome.
All right, thanks. Nice to see you all. And I guess I'll ask for the first slide there from Cheyenne. Cheyenne was kind enough to prepare a few slides here, and I'll walk through here. I will say briefly that Maine is a low tide state, and that's relevant as regards aquaculture, so that in most cases, a shorefront homeowner will own to mean low water. And the aquaculture regulations take that into account. And it has certainly impact on what kinds of aquaculture can happen in the intertidal zone and where. And for that reason, I'll say that Maine has very little aquaculture in the intertidal zone, despite the fact that we have a lot of habitat for growing things like soft-shell clams or hard clamshell oysters. And so to fill in for Cheyenne here, some of the status things that we hear in the state is that the number of leases are going up in the state, as you can tell by the leases and the limited purpose aquaculture licenses. The license itself is for a calendar year, whereas a lease can occur for up to 20 years. Most of the activity is for oyster production. Probably second, the new activity is for seaweed. And as you might expect, most of the oyster production is relatively shoal water. The Department of Marine Resources, which is hugely busy, it is a small department handling a very much oversized workload. They've been tracking these interactions between eelgrass and particularly shellfish farming for quite some time. My sense is that there's a lot more science that they would like to do, but they have not had the capacity. And so as a science question, one of those things that I think is principal on their minds is, what is that ebb and flow of eelgrass beds proximal to, say, a shellfish farm? Is there a positive interaction there? Is there a negative interaction? The sorts of things that we're hearing about already. Next, please. So this excerpt goes to show that eelgrass and submerged aquatic vegetation in general is part of the lease criteria that the Department of Marine Resources use to judge whether or not to grant a lease. In Maine, the DMR is the principal regulatory authority, and they work with a whole constellation of other authorities. And I'll point out here the U.S. Army Corps of Engineers. And so I can tell you from hearing both from DMR and Army Corps colleagues, and we follow their advice, is that when we're talking to new producers who are looking for siting, our recommendation is stay away from eelgrass, because that is definitely going to be a negative mark when a lease or a license goes through the review process, and it's codified right into the lease language here. Next, please. Let's see here. So the process by which the department staff implements this regulation is what you can read on the map here. So there are some resources, read on the slide here. There are some resources like an eelgrass presence map, which is GIS based. It's a little bit out of date, but I think there are plans to revisit that. And then as department staff are reviewing leases, they do a site review, and that includes either usually it's scuba diving, sometimes it's just snorkeling, and they'll look at a whole suite of factors in the environment there, including the presence or absence of eelgrass or the proximity to eelgrass. So again, presence or absence of SAVs are codified right in the implementation of the language offered in the regulation. Next, please. That might be the last one. I can't recall. Yeah, just some things that that Cheyenne has prepared for us. That we do see that eelgrass in some locations has expanded, and those might be for some of the reasons that have come up in the chat or in Lee's comments. There is definitely I'm not quite sure how to capture this challenge that she notes, because there are certainly more leases and limited purpose licenses coming on in the state. The rate at which new licenses are being approved is relatively low. So that's kind of a natural bottleneck, I suppose. And so it kind of remains to be seen how these interactions are going to happen. I will say that as regards our mussel industry and our seaweed industry, our finfish industry, both of those are much more deep water activities. And although I'm not an eelgrass expert by any stretch of the imagination, my impression is that those deep water activities mean that there's a setback from where eelgrass is versus where the farm sites are. And so it would be more like studying far field effects. And I can only echo Cheyenne's priorities here. We have a lot of really science savvy and science supportive aquaculture producers in the state. There's a lot of collaborative research that goes on between various scientists and the producers. And so I would say that the situation is good for that kind of collaborative research, where we're trying to gather the expertise from the scientific community, as well as the expertise from the industry community as well. I think I'll stop there. Thanks.
Thanks so much, Dana. Next, we're going to hear from the State of the Science in New Hampshire from Trevor Matera from New Hampshire Sea Grant.
Great, thanks, Jill. So I'll try to blast through this. I know I have a lightning talk, so we'll just go through. I'm Trevor Matera, the Habitat Program Manager with the Piscataqua Region Estuaries Partnership. Very much like Mass Bays, we are the National Estuary Program for New Hampshire and Southern Maine. If you go to the next slide, we can check out our study area here. We actually are in charge of 2 nationally significant estuaries in our region here. If you click once, you'll see the Great Bay Estuary pop up. Our entire watershed is made up of roughly over 1,000 square miles, covering New Hampshire and Southern Maine. If you click again, you'll see the second of the 2 being the Hampton Seabrook. We were blessed with these 2 significant estuaries. However, they're vastly different. And when it comes to oysters and eelgrass, you'll generally find these in the Great Bay Estuary, which will be the one we'll talk about going forward. Hampton Seabrook, again, is a very coastal estuary, very salt marsh dominated with a lot of sand. Is not as much of the oyster aquaculture or eelgrass going on. You can click. And we'll jump right into my interest in this topic. So first of all, there's sort of threefold. One is the mission of PrEP being to protect and improve the water quality of the overall health of these two estuaries. When it comes to the Great Bay estuary, these two habitats, both oysters and eelgrass, really make up the basis of those estuary habitats. They're really important to the water quality and stability and resilience of that estuary in specific. And because of that, PrEP takes a large undertaking in understanding and monitoring the health of those two habitats specifically. As my role as the habitat program manager, I also look for opportunities where we can implement either better management or habitat restoration projects. And as of recently have been looking into help either integrating eelgrass and or integrated oyster restoration between these two. And thirdly, as you'll be hearing after this presentation from Robert Atwood with the New Hampshire Fish and Game, we're really looking to support our aquaculture community. It's a burgeoning industry, and it brings a lot of support to our estuary, especially throughout the Great Bay. Slide. So, talking about how these two habitats are doing in New Hampshire, again, PrEP does the monitoring throughout the years with help from the UNH Jackson Estuarine Lab in looking at both oysters and eelgrass. You can see here that we've been doing eelgrass monitoring at the spatial scale and acreage of for many decades. And the story is pretty grim in that we've lost nearly half of our eelgrass within this system. You can see on the map on the right-hand side, a distribution comparison between the 1996 eelgrass distribution and the 2016 eelgrass distribution. This was pulled out of our State of our Estuaries report, which is a report that PrEP produces every 5 years. There's actually one coming out right now we're working on. So you'll see the new data come June of next year. And I welcome everyone to go to stateofourestuaries.org as a shameless plug to check out the report. You can click. Oh, I'm sorry. And in the next one, you'll probably hear a lot of the focus being on this area right here that the circle is covering, which is we call Little Bay. Great Bay, you can see south of that, is where most of the eelgrass is generally resides. But most of our aquaculture activity you'll be found within the Little Bay and the Piscataqua River, which is just north of that. Again, you'll see in the next presentation. There is eelgrass in that area, it comes and goes. It's a little more ephemeral, but that's generally the place where you find these two specifically integrating. Click, please. Next slide. Although Robert will be talking about our aquaculture and the amount of oysters within that, I can give you a little bit sense of the wild oyster population, because again, these two habitats are extremely important to this estuarine system. Again, you can see that since the early 90s, we've really lost up to 90% of our wild oyster populations. You can see the PrEP goal on that bar chart on the left there. We're looking to pull back nearly 10 million oysters in our estuarine system. And it's really flatlined a little bit below 5 million for quite a few years because of the two MSX and Dermo, those two casualties that have gone through the oyster population. Click. Just a couple seconds left. Great. Let's go. So State of our Estuaries, we do have an updated site suitability model in 2021. Partners from UNH and BU have updated one that was created in early 2000s. So we do have a model showing us suitability for eelgrass when it comes to restoration. In 2021 and 2022, PrEP partnered with this team to do a little bit of eelgrass restoration. 2021 is an awful year for eelgrass. I'm sure many of you saw throughout the region if you've been keeping track, most probably because of the record precipitation. However, that far right bottom photo is actually one of our successful blades of grass that popped up in southern Great Bay. And the thing about that site was that it's actually surrounded by infaunal oysters. And because of that, we've had this new interest in seeing how these two habitats really can benefit one another. Click. And lastly, so some of our successes. There's significant interest in the research community to look at these two these two habitats and how they interact. So we just had a Great Bay Research Symposium that was put on by the Great Bay National Estuarine Research Reserve. And out of that symposium, one of the ideas that came to the top amongst researchers was this interest in these two habitats specifically. So going forward, I know that's going to be on people's radar. We also have very interested and engaged oyster farmers and regulators. They are certainly come to the table. We're willing to talk with you. We have many in the aquaculture industry who either sit on some of our management committee in some cases. They will come to these symposiums, they will give their ideas, and they're absolutely willing to collaborate. And one of our biggest successes coming up is the fact that there is money on the table for these kind of projects. When it comes to restoration, especially, there's a new eye on eelgrass. There's been an eye on oysters, and I can tell you that through a significant amount of funding, we'll be presenting a restoration project with these two habitats in the coming years. Some of the challenges we're seeing, policy change is hard. It's tough getting through some of these social projects and pulling all of the people needed to get together to the table to really work out some of the goals that everyone's trying to achieve in the policy space that you're allowed because of the regulations. And we're also seeing a slight hesitancy among oyster farmers, even though I just mentioned that they're absolutely willing to collaborate. When it comes down to it, this is their livelihood on the line. So you can't go experimenting in their spaces if you're putting their livelihood and some possibly licenses at risk. And finally, future priorities and known gaps. One is actually working through some of these social problems. If we're trying to get to a policy change, we really should be bringing everyone that's these interested parties to the table, being oyster growers, being the scientists, being the regulators, and starting hashing out these ideas of challenges and what we need to figure out. And some of what actually needs to figure out are these different impacts across aquaculture methods, as mentioned, as well as some of these effects at the spatial scale. And finally, if you would like to click, my perception of the nature of aquaculture eelgrass interaction is hopeful. I think there are some benefits here that can be harnessed at the spatial scale. And I think we have the partners in place and the minds really thinking about this to start chipping away at this problem and cracking this nut. Thanks so much for the time.
Thanks, Trevor. Now we'll get the regulatory perspective, also in New Hampshire, from the Fish and Game Department.
Hi, can you hear me all right? Hi,
That's
my name's Robert Atwood. I'm with the New Hampshire Fish and Game Department. And if you can go next slide, we'll go right into it. So Trevor gave some background on this, but aquaculture in New Hampshire has really exploded in the last decade or so. You can see from this map, you go back a decade, we had 1 or 2 oyster sites. As of 2022, we have 28 oyster aquaculture sites. That's about 80 acres. Last year, we had about 800,000 oysters that were harvested. The majority of the sites are in Little Bay. We do have 2 aquaculture sites in Hampton Harbor that have floating gear. That's the only area where we have floating gear. In Little Bay, most of the gear is just condos and trays, and also planting oysters directly on the bottom. Next slide. So Trevor showed this slide, but it's just information that we get from PrEP showing what we use for our surveys, get an idea of what kind of eelgrass is out there, showing the decline that we've seen in the last few decades. So next slide. So this goes into just Little Bay, where the majority of our oyster aquaculture is. The yellow area is oyster aquaculture sites. So in Little Bay, a site can be a maximum of 4.5 acres. There has to be at least 150-foot buffer between sites. And the green area on the map is kind of the eelgrass from eelgrass surveys over the last decade. So when we do site surveys or look at these areas, we're looking to see the historic extent of where eelgrass was and where people want to have an aquaculture site. You can see from this map, there is kind of a limited area left. You can see there's been a decline in the last few years of what is actually available and licenses that we do issue. Next slide. So this is the regulatory language that we use for issuing aquaculture sites. So basically what this says is the law that we use. we make sure that the proposed aquaculture operation does not pose any unacceptable risk to the biological community. So it's not going to damage any SAV or oyster reef or any other shellfish that's in the area, and also does not conflict negatively with a recreational or the commercial use that's currently being conducted in that area. Next slide. So this is just going into more detail when we do a site assessment. So typically we get an aquaculture application, and then myself and another biologist will go out to the site and conduct a scuba dive survey. And we're just looking for what's currently there and if it's a suitable site for aquaculture. If we find eelgrass, we automatically don't proceed in the process. If we find like a good area of SAV or a current shellfish bed or anything else, we also stop the process. If it goes past that stage, we then have a public hearing to look into the recreational and commercial impact that those sites would have before going forward and issuing a license. Our aquaculture licenses are a 1-year or a 5-year license that can automatically be renewed if they are following all the conditions in their license. And we can craft these conditions to suit that area of what's going on and concerns that we have from the public. Next slide. So this last slide going through the observations, the successes that we've had. As an agency, we're looking to protect the eelgrass habitat. We want to make sure that these aquaculture sites don't cause harm to what is currently there. And we know that the growers are aware of the eelgrass benefits. And then the challenges, like Trevor said, is the hesitancy of the aquaculture farmers. There's some concern that, or this thought that if eelgrass moves into their site, that they might lose their site. But we've been very clear that current aquaculture licenses will not be revoked if eelgrass starts to move within the site. But it's still a fear, especially with new research projects and the idea of possibly planting eelgrass within aquaculture sites to see that interaction. So there has to be more conversations regarding that. Also, on one of the previous maps where I showed the aquaculture sites in Little Bay, I showed the eelgrass on the eastern side of Little Bay. There's a lot of eelgrass in the last few years, but it's ephemeral. It dies, it's there in the spring and it all dies back. So there's a lot of interest for aquaculture to move in that area. But with updated wastewater facilities, we're hopeful that that area, the eelgrass, will be able to stay there, and that will continue to stay closed. We're continuing to monitor it. If a decade from now, if it seems like the eelgrass really isn't flourishing there or it's all dying back, there might be conversations to open small areas of it. And then the future priorities, like I said, we want to make sure that the aquaculture industry knows that we're not going to revoke licenses if eelgrass starts going within sites, and to continue to protect the eelgrass habitat.
Great, thank you, Robert. We're going to move down to Massachusetts now and hear from Abigail Archer from the Woods Hole Sea Grant Program.
Thanks, Jill. Thanks, Danny. Hello, everyone. My name is Abigail Archer. I'm an extension agent, fisheries and aquaculture specialist with Woods Hole Sea Grant and also Barnstable County, which is the 15 towns of Cape Cod. I work for Cape Cod Cooperative Extension. Next slide, please. So I am not an eelgrass researcher. My role in this was to be an aggregator of information, which is often the role of an extension agent. So I reached out to about 15 people. I spoke with 11 of them in a smattering of locations. I tried to get some good geographic representation. We have a lot of different embayments. So this is not a comprehensive review. This reflects the people that I spoke with. I do have some personal experience with eelgrass though. So growing up, spending time on the beach in Wellfleet, which is out on Cape Cod Bay, big rafts of eelgrass would wash up. I have definitely seen less of it washing up in my personal experience. It was great material for throwing at my brother. It is also how I learned that I'm a different age than the people I was talking to when I was an environmental educator at Wellfleet Bay Wildlife Sanctuary, because I used to refer to eelgrass as being like cassette tape, but then folks wouldn't know what I was talking about anymore because they weren't buying their music on cassette. So just a cultural reference point. And then the other, which was a really cool opportunity for me. So I used to rent an upstairs apartment from a family, fishing and shellfishing family in Wellfleet, and their cultural practice was to gather dried seagrass and also salt meadow hay. In the winter, they would put it around the basement area. It wasn't an actual basement; it was, just sort of the foundation area as extra installation in the winter. Rain and snow would wash salt away from that material, and then we would put it on the garden afterwards. So eelgrass was a big part of my life for a while. Next, please. So I did not find any instances of research on shellfish aquaculture and eelgrass, but that does not mean that eelgrass is not well studied in Massachusetts. This is just a smattering. It is well mapped if you are looking to figure out where eelgrass is in Massachusetts. The DEP and DMF have a tremendous amount of resources, and you can access an online viewer to see it. Also, there is a change study, so it's 12-year mapping analysis of where eelgrass has declined, in some cases completely. It was there, in the beginning years of the mapping effort, and then when they went to map again, there was no eelgrass. That has sort of been the overall story of eelgrass on Cape Cod. I should say most of the people I spoke with are in the southern portion of the state. And quite a few studies are focused on how light has been limited to eelgrass because of eutrophication. And the big push these days is to figure out how to reduce nitrogen input to embayments in order to improve, not have the water be as turbid, and to improve the amount of light that eelgrass beds are getting. And towns are making great progress with coming up with their nitrogen mitigation programs. Woods Hole Sea Grant, so we do a biennial research opportunity. There's only one study in the past 10 years that's focused on eelgrass, though, so that hasn't been a big focus of those research dollars. Next, please. Buzzards Bay Coalition has spent a tremendous amount of time mapping and monitoring the eelgrass resources. Some of you are probably familiar with Joe Costa's work. He did his PhD on eelgrass. So there's a lot of information about eelgrass in Buzzards Bay. The study and monitoring project that is going on is looking at conservation moorings. So this, they've got about 3 years worth of data so far, I believe, and Buzzards Bay Coalition will be putting together a report on this. And the idea is to reduce those scarring effects that Lee was showing in his initial presentation. So a report will be coming out. Next, please. Some quotes from people who did have research questions. So one in town of Barnstable, they had questions about, what's causing the patchy nature of eelgrass in their town. There is an instance in Edgartown, Great Pond, and Martha's Vineyard of eelgrass returning in an area that does have shellfish aquaculture. But the person making this observation said that could be due to a number of other things. Next, please. This is the last slide. I did hear from another person from Martha's Vineyard just this morning, and they have questions about how oyster pseudofeces could be impacting the sediment chemistry and perhaps making more nitrogen more readily available, or maybe less available for eelgrass in particular areas. So that's another study question. Wrapping up with observations, successes, there really is a focus on reducing nitrogen inputs on embayments through sewering and stormwater and getting people to switch to nitrogen reducing septic systems. Challenges is, despite that work, it's early days and eelgrass is not increasing yet. Future priorities are to keep monitoring for presence and absence, especially as these nutrient watershed plans are implemented, so we know if they're helping. And I would say the nature of aquaculture eelgrass interactions is unknown in the southern part of Massachusetts, but definitely deserving of study. Thank you.
Thanks, Abigail. We'll stay with Massachusetts, but move to the regulatory perspective with Chrissy Petipes.
Okay, thank you. So I'm Chrissy Petipes. I'm with the Massachusetts Division of Marine Fisheries. We're the state agency that regulates all marine fisheries, including aquaculture. This slide shows some of our intertidal aquaculture and some of our surveys that we've done in an area where we've actually had to reject a proposed site due to aquaculture, due to eelgrass in the area. Okay. Next, please. So these maps generally show where our aquaculture sites are. The vast majority of our aquaculture sites are shellfish aquaculture, and in Massachusetts, we have home rule where the municipalities decide whether they want to allow aquaculture, and they are the licensing authority for shellfish aquaculture. For other types of aquaculture, such as seaweed and finfish, we do not have a leasing structure. So our leasing structure is specific to bivalves. But as I said, the vast majority of aquaculture is bivalve aquaculture, and greater than 95% of that is oyster aquaculture. Thanks. So we have in intertidal areas, we have several types of gears that, much of these gears have already been shown. We typically have bottom cages, we have rack and bag, we have hanging bag. We also have some growers who are using predator nets to protect clams. Okay, we have subtidal aquacultures, most of which is floating cages. We do have some that have suspended aquaculture. We also have some aquaculturists, some cultures who bottom broadcast and then drag them up. And of course, there are some cases of long lines. And our extension agents have produced this really great mapping tool for prospective growers. And it's called Shellfast. And what this does is provides a lot of different mapping tools and layers that can be used to help prospective growers pick a site that will minimize conflicts with both resources, with areas of critical environmental concern and such. So as Abigail mentioned, our Department of Environmental Protection has an eelgrass mapping program, and the Shellfast mapping tool includes the current eelgrass bed distribution as well as historic eelgrass beds. And we ask that prospective aquaculturists, even though they're going to their town first, we ask them to do some homework. And these include using the mapping tool, using the layers for current and recent mapped eelgrass and the historically mapped eelgrass, and also to consult with their shellfish constable. And again, as Abigail said, Massachusetts, like so many other areas, have experienced a decrease in eelgrass. So DMF has to certify aquaculture sites, shellfish aquaculture sites. So as I said, the towns basically are the starting point. The town could say, nope, no aquaculture in my municipality, and then you're pretty much done, unless you can somehow, rally the troops locally to get a change of opinion. But if the town does want to support aquaculture, then there is a process, a public hearing process for the select board or city council to vote to approve a specific site. And then that town will submit a request to DMF so that we can go certify the site. And so the DMF certification is authorized through our Chapter 130, Section 57, requires DMF to certify that issuance of the site will have no substantial adverse effects on the shellfish or other natural resources. And our inspection will make sure that there's no eelgrass on the site and that there is a minimum of 20-foot buffer between any eelgrass or SAV of concern. And larger buffers may be required if there's dragging as part of the operation. So we also look at infauna. So that's that picture. If we see eelgrass, we're not digging up the eelgrass. The infaunal survey is pretty much done. And there is no monitoring of the eelgrass interactions once the site is granted. Yep. Next. It's not allowing me to, okay. And so basically this is the last slide. Our Massachusetts Environmental Policy Act requires that projects that have significant environmental impacts be reviewed, and eelgrass is an important aspect of making that assessment. Eelgrass is afforded protection under our Massachusetts Protection Act regulations. Challenges, the relationship between eelgrass and aquaculture, as has already been stated, is not that clear. We've had eelgrass pop up in aquaculture sites where none existed before, and we can have applicants getting upset when we just find a few shoots here and there. They don't understand why we might make them change due to just a few shoots. And then future considerations, we've had some internal considerations about whether we should just not allow eelgrass aquaculture sites to go where eelgrass has been mapped historically within the last 5 years. So that's something we're considering. So thank you.
Thanks so much, Chrissy. So we'll move down to Rhode Island now with our scientific presentation from Susie Avazian et al.
Thanks so much, Jill. Good afternoon. As Jill said, my name is Susie Avazian. My colleagues and I are from the U.S. Environmental Protection Agency, from the Region 1 office in Boston, as well as the Office of Research and Development Research Lab in Narragansett, Rhode Island. With the simultaneous attention on oyster aquaculture for food and economic benefits and restoration for non-extractive services, our group has researched attributes of oysters over the last several years in Rhode Island salt ponds. Next slide, please. Today, I'd like to present our new research project designed to study relationships between oyster aquaculture and seagrass. We've taken a multi-pronged wide approach to the investigation, and we have 7 main objectives. First, we'd like to take a landscape level look at relationships between seagrass and oysters using maps generated through remote sensing applications and aquaculture information from Rhode Island and hopefully Massachusetts, so we can cover the whole southern New England area. We are also using remote sensing to have a look at chlorophyll A abundance, both proximal and distal to aquaculture leases. We're examining biological, chemical, physical characteristics at aquaculture, seagrass, and sediment under seagrass, again at distances from the aquaculture site. We're investigating greenhouse gas fluxes using a Picaro analyzer over seagrass beds in the oyster farms and in a controlled mesocosm experiment in our lab. We'll be using spectral satellite data to extrapolate aquaculture site-specific values to a broader scale to examine SAV distribution and biomass, shoot density, and carbon content. We'd also like to take a look at the potential social benefits of restoring seagrass and the costs associated with seagrass loss in terms of greenhouse gas mitigation. And lastly, we'd like to provide scientific communication about these results to the EPA regions, state partners, and all of our stakeholders. Next slide, please. Our site selection for our first year, this last summer, was facilitated by the use of the SAV mapping exercise led by Mike Bradley at the University of Rhode Island, as well as others in Rhode Island. This example is from Potter's Pond, which is a Rhode Island salt pond on the south coast of Rhode Island. Here you can see outlined in yellow a 7-acre aquaculture farm. It's an oyster farm, and around it, you can see in pink the SAV that was surveyed in 2012, then in green, 2016, and in blue, 2021. So to the point we've discussed of the seagrass moving and changing its distribution, this highlights that quite nicely. Next slide, please. We're currently using this site for our study with the permission of the aquaculturalists. Our 2021 field season was dedicated to working out our protocols and procedures. And what we've arrived at currently is with this 7-acre site, we've created 5 zones with 15 sites, and they are all labeled here. We have sites just inside the aquaculture farm, and then we have 3 zones where we find seagrass, just outside the aquaculture farm, at a mid-distance and at a far distance from the aquaculture buffers farm area. And then we have 3 sites there on the left of the slide that are the control sites in a sandy area. You can also see 2 X's. Those X's represent our upstream and downstream water clarity sites, where we're measuring water clarity every 2 weeks after establishing the current flow. So at these 15 sites this last year, during the summer and the fall, we measured greenhouse gases, and we had vegetation counts and samples of the SAV and the macroalgae, which we're taking back to the lab. In the fall, we did our greenhouse gases again, but we also took sediment cores at each of those 15 sites. Next slide, please. As the oyster and eelgrass interactions can be complex and the result of multiple stressors, as we heard early on, we're attempting to quantify a wide suite of biological, chemical, and physical factors. These factors are listed under each of the 5 components of the study. So we have a water clarity, greenhouse gas, seagrass, sediment, and satellite imagery section, and you can see the various things that we're measuring. We successfully collected all of our measurements in 2022. We'll be working on those results this winter, and that will inform us for our 23 season. Last slide, please. Lastly, just quickly, we're planning in the planning stages for our summer 23 greenhouse gas flux measurements at 2 densities of seagrass, and these will be measured in mesocosms at our lab in Narragansett. So last slide, we look forward to presenting our results to you at a future date, and you can see oysters are a big part of our Rhode Island culture at the moment. Thank you.
Thanks so much, Susie. All right, the Rhode Island Regulator presentation will be by Ben Goach. Welcome, Ben.
Hi, can you hear me okay?
Sounds good.
Great. I'll keep this pretty quick. Susie did a great job. But this is our main regulation that touches upon eelgrass and aquaculture from the aquaculture section of our coastal resource management plan, i.e. the Red Book, which simply states leases may not be cited where eelgrass or widgeon grass or other grass of concern exists. That's my emphasis there. So where does it exist? Well, that's always the question, as we've seen. Next slide. So this is some of the policies that would determine where it would exist, how we would determine that. And this is under the section of submerged aquatic vegetation and habitats of concern. That's its own section in our program. But for applications proposed under, as you can see, I highlighted K there, that is our aquaculture section. Survey is generally required if the staff determines that one is needed. Basically, we use our aerial survey imagery that Susie showed there. Mike Bradley at URI takes that imagery from flyovers and through his program is able to determine the visual signature of eelgrass, and then we go and ground truth that. This last year in 2021, I was involved in ground truthing many of the sites throughout Narragansett Bay and the coastal salt ponds. We house the data from those surveys on our CRMC website as well. And if an application comes in and it's in an area that has previously had eelgrass as determined by one of these surveys, oftentimes we will not recommend the application move forward, or we will do a closer investigation to see if eelgrass is present. Now, if eelgrass is not present, There's no barrier for the application to move forward. But importantly, we do our surveys during the peak biomass season, as you can see here, which is a little different for the bay and our coastal salt ponds. Narragansett Bay, you can see, is July 1, September 15, and then in the coastal ponds, it's July 1 and August 15. It does make doing these surveys a little challenging, but luckily we are a little roady, and we only have so much territory to cover compared to perhaps Maine or something. You can go to the next slide. And this, of course, it is the kind of grandfather clause, I call it. If a farm is sited, eelgrass comes up within the farm or near the farm, it is no threat to the farm's continuing operation, and we consider it grandfathered in, based on the requirements otherwise. However, future expansions are still subject to review. So if you do have eelgrass and it comes up and around your farm, you may not be able to expand that operation in the future. And that has happened in the past, but I guess in some ways it's the victim of their own success in helping the environment. But in general, eelgrass interactions in Rhode Island, by design, have we've tried to keep them to a minimum. Most of the important areas for aquaculture were kind of developed with that in mind, and there is not eelgrass present nearby, nor has there been. Our survey data goes back to 2006, and it's been done on a regular basis every 3 to 5 years. And I think my last slide, or I think next slide. All right, second to last slide. So this is our research vessel, the Jack Reed. That is the CRMC vessel that we use to do these surveys in Narragansett Bay. And you can see there one of our towed camera images. In the seagrass map that we create, we do include these images in various places around the bay, so you can actually click and see what that particular area looked like during that survey. Next slide. And here's another example of kind of a zoomed out view of the eelgrass map, where I included a link to it for anyone who wants to explore that. So you can see it's 2006, 2012. We had a little bit of a gap between 2016 and 2021. I think that, of course, was also hindered by COVID, but we were able to get that done. And you can see on the right-hand side, a floating gear operation. On the left-hand side of the picture, and then down in the right-hand corner is another farm. And you can see these farms were sited to avoid these patches of eelgrass that have been there during different surveyed years. We also consult on all applications with our Department of Environmental Management, and they'll bring any concerns of potential eelgrass habitat to our attention. But all applications are subject to a shellfish survey as well. And during that shellfish survey, where we tried to get a feel for the density of shellfish on a potential site, wild shellfish, of course, we're looking out for eelgrass and widgeon grass as well. Yeah, that's all I have. Thank you.
Thank you, Ben. Next, we'll hear from Connecticut. Both speakers will share the same slide deck. We have David Carey from Connecticut's Bureau of Aquaculture and Tessa from Connecticut Sea Grant and Yukon Extension.
Hi, everyone. Can you hear me?
Yes.
Great. My name is Tessa Getchis, and I'm an extension educator with Connecticut Sea Grant and Yukon Extension. Today, I'm giving this presentation on behalf of David Carey, who is our state aquaculture coordinator, and the state's aquaculture permitting work group. This work group is comprised of state and federal regulators, and they review applications for aquaculture activity in our state. Recently, the work group has been collaborating with another team, and they're preparing an eelgrass management and restoration strategy for the entire Long Island Sound. And so we've highlighted some of their interests and efforts here. Next slide. So marine aquaculture is growing in Connecticut, And in terms of space and production, the industry is still primarily extensive bottom culture. Though over the past 2 decades, surface and submerged culture has been slowly expanding. So we have some surface cages and floating bags, as well as bottom cages. We also have a handful of new kelp farms. Together, aquaculture, natural shellfish beds, and recreational harvest areas cover nearly 80,000 acres, or 20% of the sound area. Eelgrass populations, however, are at a fraction of historic coverage, and eelgrass is ephemeral. It's not expanding as it says in the slide here. I guess maybe we were hopeful. But in fact, the overall acreage in Long Island Sound has declined to around 1,400 acres. That was as of the last survey that was conducted in 2017. The state does plan to conduct a statewide survey in 2023. That we are aware of, the overlap between aquaculture and eelgrass is limited to one area in Eastern Long Island Sound, and I will show you that in the next slide. I should mention that prospective producers are required to conduct an eelgrass survey and include that with their application. And regulators, extension staff, scientists have been working together to address the current and future potential for these interactions and address any issues that we may face with regard to non-compliance. Next slide. So at the top of the screen here, what you can see in all these colored polygons are the commercial areas, again, the natural shellfish beds, recreational harvest areas, as well as kelp areas. The map at the bottom of the page shows the extent of the eelgrass beds, at least, again, with respect to that survey conducted in 2017. And if you click to the next slide, you can see where the overlap occurs. And again, it's quite limited. In this map, the eelgrass areas are the gray polygons, and the blue shaded areas are the shellfish farms that have bottom cages sited on them. You can see that the overlap to the left there are 2 lease sites that are operated by one farm, but there are other sites that are in close proximity to eelgrass, and those are the ones that the aquaculture permitting work group are paying attention to. Next slide. And even though that there is little overlap, there have been multiple initiatives right now to grow both the eelgrass resource as well as the shellfish aquaculture resource. So in 2016, the state published a shellfish vision plan to grow aquaculture as well as recreational shellfisheries, and we have seen growth in both since then. More recently, the state completed a shellfish restoration plan. So that is intended to expand upon our natural oyster beds. And just this year, a Long Island Sound eelgrass management and restoration strategy, which I previously mentioned, was drafted. So hopefully we'll see the expansion of eelgrass in the Sound. With respect to research, there is one published study that investigated the interaction of aquaculture and eelgrass at the site that we showed you on the last slide. And we're also considering the previously mentioned research findings from across the globe as aquaculture expands. In Connecticut, we're looking at how the practices are changing, the gear is changing, and again, how these two overlap and how they can be compatible. Next slide. So as the interest in gear became more prevalent in the early 2000s, state and federal regulators worked together and they established a policy of a 25-foot buffer between the aquaculture gear and eelgrass beds. So in many instances, the lease area may include eelgrass, but the gear area, again, had to have a buffer. That was adapted later as a condition in the Army Corps permit, which still exists today. At the time, there was no overlap between aquaculture and eelgrass, but there was concern about the potential. And then again, as I demonstrated in that last slide, there was a site where eelgrass repopulated a permitted gear site, and it became a compliance issue. But because that research had been conducted previously on the site by Jamie Vaudry and her colleagues, the Corps determined that there were minimal impacts to the eelgrass, and they were able to eliminate the non-compliant status. So that was an issue for quite some time. Again, we're looking at the potential for other overlaps. Next slide.
So just to summarize, first and foremost, in Connecticut, we're very excited that regulators, extension scientists, and others have been working together to align these respective management plans to make sure that where overlap exists, we can address it to make sure it's compatible and rewrite policy if necessary. It's been really important for us to be able to communicate the type and extent of aquaculture gear that exists, as well as the extent of eelgrass populations, and recognize that eelgrass may be moving around, so we need to pay attention to how that affects aquaculture operations. We also recognize that the mapping technology and the frequency of the mapping need to be improved so that we can make more informed decisions in Connecticut. We do keep up to date in mapping the aquaculture gear areas, but we also, while those gear areas are out there and mapped, those may change as well. And so we have to keep up with those and share that information. We do have a mapping atlas similar to other states, and that's where these maps are derived from. It's been really helpful to have that one geographically relevant research study, but we anticipate that we may need more depending on, again, whether the gear and methods are diversified in our state. So the main challenge going forward is going to be working towards, again, understanding these interactions as the resources expand, both eelgrass and aquaculture, but we have plans in place and progress to address this. So with that, I'll say thank you.
Thanks, Tessa. I'm so glad you could cover both the regulatory and the science perspectives there. Our last lightning talk will be from NOAA, Caitlin Shaw.
Yes, hello, can you hear me?
Yes, we can.
All right. I'm so glad to be here with you, and also to see Tessa and Jamie are here. I worked with them in undergrad actually on that paper, so it's really inspiring to see people who served as my mentors early on in my career. So I'm with the Habitat and Ecosystem Services Division at NOAA Fisheries, and today I'll be talking about essential fish habitat consultations. Next slide, please. So as an overview, when federal action agencies are reviewing permits for aquaculture, they're required to consult with us on projects that may impact essential fish habitat. And so project-specific consultations oftentimes occur for activities that require additional coordination with the applicant. And we also have programmatic consultations, which exist for activities that we have really long-term knowledge regarding their impacts, and we can provide conservation recommendations that are aligned with that knowledge that we've developed over time with the Army Corps of Engineers or other federal action agencies. So we currently have a programmatic in place, but we are updating it to increase efficiencies for coordination. So EFH is defined as those waters and substrate necessary for fish spawning, breeding, feeding, or growth to maturity, and that includes special aquatic sites, which includes eelgrass, and much of our coastal concerns have to do with eelgrass and mudflats and other salt marsh habitats. So we recommend and provide conservation recommendations to avoid, minimize, and mitigate those adverse effects. Next slide, please. In order to do so, I've been following the chat, and there are some questions about the historic eelgrass mapping being used. So the reason for using historic eelgrass mapping is because, as it was discussed earlier, there can be changes in SAV habitat, and if it historically occurred or recently occurred, we would want to see an SAV delineation site-specific in order to confirm the presence or absence in a certain area. So an on-site survey during the growing season is the best approach for the delineation, but also state resources that have been discussed or the Northeast Ocean Data Portal can be used to indicate that there has been no presence for at least 5 years. And you are able to use an on-site survey that has been done in the last 3 years if there was a nearby project that had been done that developed a delineation. Aerial photography could be used in the case that there's no state or online mapping, but that's mostly just to confirm that it hasn't been present for 5 years, in which case we wouldn't require an on-site survey. Next slide, please. So I see Corey Rose from the Army Corps of Engineers is here, and one of our successes during the programmatic update is that we worked together to, well, actually she drafted this nice figure looking at calculating different types of gear impact. We can also call them interactions, especially in the cases if there is eelgrass growing into a site, you might want to use the word interaction rather than impact. But this just gives us an approach throughout the greater Atlantic region so that when the program managers are coming in with gear impact calculations, that they're being done in a similar fashion, for at least for our essential fish habitat consultations. Next slide, please. Sorry. So some of the successes that we have encountered, and it seemed to be much greater than it just was revealed in Tessa's talk, but that SAV encroachment occurring is not, that is a success. I mean, it shows that they can coexist. In the cases where a site changes gear type and needs to come back for core permitting, there are other activities within the programmatic that allow up to 100 square feet of impact with mitigation. And for the case, these minor cases where SAV is encroaching into a site that has aquaculture, that could be very specific to that site. So the mitigation might be for them to retransplant the SAV that has encroached into another area of the lease that's not planning to be used. So it's very site specific. Updating these recommendations and including them in a programmatic approach is going to take time because these are unique situations. So challenges are encroachment, and expanding lease or gear type is a new occurrence for us. And we need to collaborate through abbreviated project-specific consultations to understand those BMPs that are effective and then incorporate them into a programmatic approach moving forward. So we recognize that there's a need to understand this geography and gear types, and really understanding what's at that specific lease is very important in order to develop that understanding moving forward for any programmatic incorporation. Thank you so much.
That wraps up our lightning talks. Let me just quickly say thank you so much to everyone who gave one of these very challenging talks today. I know a lightning talk is harder than a traditional talk in many cases. We did promise a break. We're going to do our 5 minutes right now. You are welcome to stay and use the chat or communicate off mute with each other if you like. The timer's going there. We're going to start again promptly when that timer hits 0. So please take a moment, get your coffee and your water and so forth. We'll see you soon.
Jill, I like the timer, but do we get like any timeouts?
What do you mean?
Well, I feel like I'm at a football game, you know,
Yes.
the 2-minute warning, and now we're down below that. And
Yep, you get in real trouble if you're not back before the end.
Food for thought. We really got to think of something harsh for next time.
It stresses me out for sure, the timer,
Little bit.
but we need it.
All right. Welcome back, everybody. So I'm taking it on from here. We are going to be going into some breakout rooms. I know several people in Massachusetts have a meeting at 3. So those who are in your breakout rooms, feel free. Obviously, you're going to need to leave when you need to leave. We have fairly large groups, so there still will be a robust conversation in there. I should note that within each room, we're not going to be recording those conversations, so speak more freely if you want. There's going to be a moderator in each room, and they will give you a link to your room specific notes. Somebody needs to take notes. It does not have to be that moderator. We're really looking for these 3 questions to be answered. What are the management gaps? What are the scientific gaps? And what do we want to know from industry? As we're going to follow up this event with some information gathering from growers, specifically in Massachusetts, though we're going to be looking, making it so that we can look beyond and really get the perspective from the ground. Other than that, we're going to do this for about 25 minutes. All right, and the other piece I wanted to highlight was that at the end of the 25 minutes, you're going to need to select somebody to share out. We're going to have a larger group discussion towards the end. Please do make bold just 2 or 3 items, only 2 or 3 items, no more, that are the most valuable. And if you have any thoughts that you want to submit anonymously so that they get gathered by everything we're pulling together, but you don't necessarily want your name attached to it, there is a link down here for an anonymous survey feedback form. And with that, I'm gonna open the rooms. I think I have everybody is assigned somewhere. So we'll see you back in about 25 minutes. Room 1, I'll be in there in a second because I'll be your moderator and give you the link when we get in there. And welcome. People are still coming in.
We needed some more time there, Danny.
I know this conversation is it's a big one.
Yes.
What I'm sharing my screen, right?
Yes,
yeah,
you are.
All right, so I'm going to put in the chat. So all of the notes that we just typed up is getting compiled into this master slide deck. I'm going to share out the link to this. Anybody can go in and view these notes, not change them. But as we do our share out, I'm going to be asking each room to provide just 2 or 3 items that rose to the top as priorities. And if you want to follow along on your own, you can do so by going to there. And you just might have to update each slide when you go to it, like I just did. And it's working. Okay, so I'm going to ask breakout room 1 to go first, and that was the group I was in.
All right, I'm going to report out for the group. So we discussed many things, but the 3 ones that we put in bold are under management gaps, to get a working definition arrived at by collaboration, consensus, dare we say, on what constitutes the edge of a subaquatic vegetation meadow, an eelgrass meadow, and what considers, or what the extent of a meadow is, and getting working definition that's ecologically relevant, both in terms of ecosystem services and then like how it's actually affecting the eelgrass biology and life cycle. Under the scientific gaps, what are there practical management efforts that shellfish farmers can take, also harbor masters, and that could be to maximize the ecosystem services of shellfish aquaculture, information that could be used for development of best management practices, things, for example, like density, gear placement, moorings, and anchors. And then what would be useful to know from the grower's perspective, we talked about methodology, and it's sort of a delicate path to determining that. What is the incentive for a shellfish grower to talk about this? And so we need to figure out like what concerns would a grower have in engaging in a conversation on this topic when there's potentially quite a bit at stake for them. That's it.
Thank you. Breakout room 2.
Yes, that was my room. Oh, my bolds went away, unfortunately. Yeah, I'll just remember what we were bolding there.
Let me see if I can fix
Oh, it might need to be refreshed.
Yeah.
Oh, there it is.
There you go.
Thank you. Yeah, we talked a lot about that encroaching issue. It's such a hurdle in the regulatory realm, but it also trickles into scientific. So there's not a great way to deal with eelgrass encroaching into a lease area. And it's not supported, that situation is not supported in the federal regulations. But the federal regulations won't change without the science to back it up. So we sort of need to compile all 3 of these columns into one solution where we have appropriate demonstration lease sites where we could test out some of these things. We had some nice discussion about where and who could manage those sorts of things, or just starting immediately with the growers and trying to do experimental work on the grower sites. But what will it take to get that buy-in from them? So all of the fields sort of mesh together there, but we think it's really important that any incentive whatsoever to hide or remove eelgrass from a site really just needs to be removed. There's no win situation there where there's that incentive. So there could be a regulatory solution to that. And another thing that we were talking about and would have loved more time about is really that historically previously mapped eelgrass question. If it was mapped in the last 5 years or even in the last 20 years, isn't that an indication that a site might be suitable to support eelgrass again? And even if grass is not there the day of an agency survey, is it still worthy of protection? But we don't have an answer to that. Just an interesting management gap question we came up with.
Awesome, thank you. And breakout room 3. And that would be Pam's
Suzanne,
room.
you're muted.
Sorry, thank you. Under the management gaps, we also wrestled with the question about the buffer zones. They were sometimes non-existent for certain states and sometimes inconsistent. So certainly more information was needed about that. And depending on what was established, that would be something the growers would want to understand and be on board with. For the science gaps, we were also talking about mapping, that it's lacking in some areas, and that then limits the siting and protection. We had, I guess, bolded quite a few of the scientific gap questions, which you can see there. So we thought maybe an applied research effort was needed to collect some more regional specific information about the impacts or benefits to aquaculture and seagrass being near one another. And then trying to obtain research permits, and this could go either under the management gaps or the scientific gaps, but I know this was discussed in Rhode Island at one point very briefly with Ben's predecessor, was trying to get a research permit so that you could create a little aquaculture farm, the researcher could, and then you could carry out your research there without interrupting the procedures of the aquaculturalists. And from the grower's perspective, with all of the research and management questions that exist, their willingness to participate would be vital. And lastly, we looked at the differences between wild harvest or harvest of wild populations being different than aquaculture. So are the regulations the same? Are they different? Where they're different, why are they different? How does that impact the aquaculturalist?
Fantastic. And group 4. It's Julie's room.
Right. Yep. Many of the same topics were discussed in our group. One of the big management ideas was that we will need to accept that there's going to be overlap between eelgrass and aquaculture going forward, because both are important, resources, areas of interest. And then we need to start thinking about other uses of aquatic habitat that may use the same type of habitat, for instance, offshore wind cables coming ashore, which will often be coming ashore in the same kind of habitat that aquaculture likes and that eelgrass likes. So that's something that might need to be incorporated into future management design. We also talked about maps quite a bit, but the subject of how to use the maps was kind of an important one that came up. It's not enough just to say, well, eelgrass was here 5 years ago, but maybe it would be a better idea to use predictive models, even sort of probabilistically predictive models based on sediment type, based on hydrology. So you can say, oh, this area has a 10% chance of eelgrass coming back. This area has a 90% chance of eelgrass coming back. So, let's manage it accordingly. One of the big questions of what types of gear of science was what types of gear have what impacts. There are so many different ways of growing oysters and farming oysters. Which ones may be more beneficial or less beneficial to eelgrass growth? And same questions from the grower's perspective. What happens if SAB encroaches on the site? What are ways to incentivize growers to want to support eelgrass growth? It came up with ideas like give them rewards for having eelgrass show up on their site, right? Give them a gold star, make it a positive thing. And there's one program, you can see the link here under management gaps in Save the Sound. They have started a project where they're planting eelgrass seeds with dissolvable glue onto live clam shells and then broadcasting the clams. So the clams plant the seeds for you, and then the glue dissolves and the seed germinates and you get a new eelgrass meadow. So those are some of the highlights from our discussion, and it could have gone on for much longer.
Awesome, thank you. Room 5. Did I not get the, see if I can get the bold back.
Yeah, hi. Yeah, can you make it a little bigger, please?
Yep, I'm just getting the bold, the bold back. There you go.
Yeah, thank you very much. Yeah, so we had, again, a lot of overlap with what's been said already. And we would have done with much longer time. But just to pick a few points that were kind of made, the 5-year time scale and how much changes can happen over the time. Is that enough? Given that, with climate change and sea level rise coming into the future, how will that change the needs and what we're looking for in terms of suitability for aquaculture? Let's say, especially for intertidal areas, for example, where aquaculture happens, and how will that change interaction, if possible, with, if anything, with eelgrass as well. So that keeping that, in mind, changes that can come over time with sea level rise, etc., into the future is really important as well as we look into management solutions. In terms of the science gaps, there were many as well, as we mentioned mapping, etc. But one thing that stood out was that there is not enough, or there isn't that much studies on how would eelgrass benefit from shellfish growth, or shellfish growth benefit from eelgrass. And if maybe there was more information about that, then you would get more support from growers as well in terms of helping with conservation. And this was jump a little bit into what would be useful to know from the growers' perspective. Would they be in support of this? I imagine that shellfish growers are not, all against having eelgrass around. And if there's a way of making sure that certain methods that they use, etc., could help with shellfish, with aquaculture, with eelgrass, I'm sure they will be more supportive of that. And the other thing is, there a percentage below which shellfish growth will not have impact? So kind of what is the carrying capacity, both from the commercial side as well as from the natural side or environmental side of an area? So for example, when New Brunswick, they have a 10%, I believe, threshold above which they know that that amount would not have, gross repercussions on the area. Is there a number that can be assessed, on an embayment by embayment basis from that? So basically, those are the 3 main points, but as you can see, there's a lot of other points that came up.
Thank you.
Thank you.
And the last, update this one too. There we go. The last room 6.
So yeah, we talked about what are the potential internal regulatory conflicts. And one topic that came up is the floating gear versus sinking gear, and the different kind of human health issues that could come up with contamination from birds landing on the gear, and also some navigation issues that come up with that, and how those regulatory conflicts might play out with different gear types. For the scientific gaps, we talked about what are the environmental drivers of eelgrass populations, and is aquaculture improving water quality and other factors to the point where it can actually act as a driver for habitat improvement with eelgrass. And what we'd like to know from the grower's perspective are examples of how they've been modifying their gear to address those concerns, like leaving slack on the long lines as an example, and how they're grappling with those regulations.
Thank you very much. All right. So with that, we're pretty much towards the end of our meeting. I did want to open up if there's any, we probably have 2 minutes or so for any burning follow-up questions that people wanted to put to the whole group. Anything coming up? There's been a very robust conversation in the chat, and I love it. We will be sharing the chat along with the recordings of all of this. To follow all of this up, we will be doing so I'll send the recording, we'll send a survey just to get your sense of how this went, what we missed, what we need to do. And also asking for you to let us know if you want to be engaged in future steps. The survey we send out will be anonymous. There will be a separate part of it to allow you to say that you want to stay engaged without connecting your answers to your name. And then, because we do know that this is a pretty contentious issue in many circles, and so we are trying to be as sensitive as we can to the very, as it was mentioned, there's some big livelihoods that are connected to this, and we really want to make sure that we are being as respectful of everyone as we can. And I shared the link to all of our group notes. We'll finalize those, and you can have those in your files. And following all of that, we're going to compile all of your ideas of what we want to get out of from the growers. And we're going to be doing a survey with growers. We probably will follow that up with a listening session with growers to try to get a better sense of how things are happening on the ground or in the water. And following all of that, we look to enable a little bit more cross-pollination. And it was noted there are several growers and researchers who would love to collaborate. And so we want to see where we can move forward with that. With that, I think we can let you out 2 minutes early. Wow. Thank you so much. We really, really appreciate it. Feel free to reach out to Jill or myself if you have any follow-up questions, and we will hope to be in touch. We'll send something out by the end of the week to follow up.
Thanks, everybody.
Thank you very much.
Thank you.
Thank you all.
Thank you all.
Thank you.
Good job, Jill and Danny.
Thank you for all of our moderators. Thank you so much.
Yeah, great meeting.
And all our presenters and all of them I missed.